Okay, let's unpack this. Imagine standing in a wide open field, flat and empty, maybe just a couple of years back.
Right. Just bare land.
Now picture that exact same spot totally transformed. I mean, not just buildings, but with this cutting edge tech and sheer scale that makes you really stop and think.
Like, this is it.
Yeah, this is what the future of making things looks like, especially, building EVs and cars right here in America.
Hmm.
What does that amazing transformation actually involve? What are the kind of nuts and bolts or maybe the circuits and robots behind it?
That image you painted, that dramatic, fast transformation, that's exactly what the source material we're looking at puts right up front.
It's powerful.
It really is,
Yeah.
taking a totally blank slate and building something that, well, it really aims to redefine manufacturing processes.
Yeah.
It's not just like an evolution.
No.
It's presented as a really fundamental shift.
Absolutely. And for this deep dive, we get a pretty unique view into that shift. We're looking at this great in-depth article from IEEE Spectrum.
Yeah.
It takes us inside one of the most ambitious new manufacturing places on the continent, the Hyundai Motor Group Metaplant.
And this place, it's more than just another new factory for a car company. The source really positions it as a potential blueprint.
A blueprint.
Yeah, a model for what highly automated, really technologically integrated manufacturing could actually become, especially in the next few years, as industry shifts to new things like EVs.
Exactly. So our mission for you in this deep dive is pretty clear. We're going to take this really rich source material, pull out the essential insights, find those surprising details, the ones that might make you see manufacturing differently, and really try to understand what this huge factory tells us about where car production is going, especially the cutting edge of automation, AI, and sustainable practices, too.
And just to get our bearings, this Metaplant is down in Ellabell, Georgia, just outside Savannah.
Right.
And the source makes a really critical distinction here. This isn't some old plant they just fixed up or expanded.
No retrofit.
Nope. It was conceived and built completely from the ground up, specifically engineered for making EVs and hybrids.
That purpose-built idea seems key.
It's a recurring theme in the article, yeah. And according to them, it's a pretty significant advantage.
That ground-up design really feels like the foundation for everything else they're doing there. And, one of the first things that just jumps out when you read the article is the scale, the sheer, almost overwhelming scale of this place.
Oh, the size is definitely one of the defining things. It's mentioned right near the start in the source as something that just immediately impresses you.
Let's try and convey that scale somehow. We're talking about a complex of 11 interconnected buildings.
Yeah, not just one big box.
No, it's like a sprawling campus, but for manufacturing.
Yeah.
And the total floor space inside those buildings, it's staggering, 7.5 million square feet.
The article uses the word cavernous to describe the insides, and yeah, you can see why. To help you picture that, 7.5 million square feet. That's like, what, 130 football fields? Now imagine that space, not filled with fans, but with, like, sophisticated machines, complex assembly lines, hundreds of robots, thousands of people.
It's an enormous industrial ecosystem all under these roofs.
Absolutely.
In that incredible scale, it's not just about being big, right? It connects directly to their production goals. This Metaplant is explicitly designed to be North America's largest dedicated plant for EVs and hybrids.
That dedicated part is super important, like
Yeah.
you said. It means the whole layout, the workflow, the infrastructure, it's all optimized just for building EVs and hybrids.
Which are different beasts than regular cars.
Totally different requirements. They didn't have to compromise based on, old structures or old ways of doing things for combustion engines.
And the target production capacity, it reflects that optimized scale and purpose. They are aiming to crank out 500,000 vehicles, 500,000,
From this one place.
every single year.
And the source gives us a useful comparison point, just to underline how ambitious that really is. It mentions Tesla's Texas Gigafactory.
Another huge EV plant.
Right. But its stated capacity, according to the source, is 375,000 vehicles. So at 500,000, Hyundai's Metaplant is planned to have, well, significantly higher output than what the source cites for a major competitor.
To get that kind of scale and speed going from an empty field to 500,000 cars a year, that takes a massive financial commitment. The source lays out the investment.
Yeah, the total investment for the Metaplant is pegged at $7.6 billion.
Billion, with a B.
It's a staggering number. And it reflects not just, the bricks and mortar, but all the tech, the equipment, the infrastructure needed.
And the timeline is Well, it's incredibly fast, even for modern construction. The source really highlights the speed, from those bare fields to being operational.
The article notes the very first 2025 Hyundai Ioniq 5 is scheduled to roll off the line there in October 2025.
That's really soon.
Considering the scale of construction and, getting everything working,
Hmm.
going from groundbreaking to actually producing cars you can sell in just a couple of years, it's incredibly fast.
Yeah.
Speaks to a very, very aggressive schedule.
So, what exactly are they building in this 500,000 vehicle a year monster? The source points to a few key models that'll be produced there.
One really significant model mentioned is the 2026 Hyundai Ioniq 9.
Okay.
This is described as a large, three-row electric SUV.
Which is, a super important segment in the U.S. market, especially for families. The source gives some performance details, too.
Right. They mentioned it's expected to get up to 335 miles of range, which is pretty solid for a big SUV. Addresses that range anxiety concern for a lot of buyers.
Definitely.
But a particularly interesting technical detail the source emphasizes about the Ioniq 9, it's the inclusion of a native NACS connector.
Okay, the NACS connector. That detail sounds small, but it's actually a pretty big deal, isn't it?
It really is. The source points out this means Ioniq 9 owners can access the huge Tesla supercharger network directly. No adapters needed.
That's convenient.
And not just access, but crucially, use the plug-and-charge feature.
Ah, plug and charge. That's the really seamless part.
Yeah. Exactly. It's a potential game changer for the user experience. Instead of messing with apps or payment methods or dongles, you just pull up, plug in, and it starts charging automatically. Payments handled smoothly in the background.
So much simpler.
The source frames it as removing a big layer of hassle for non-Tesla EV owners who want to use a key part of the U.S. charging network. It's a direct benefit for the driver.
And besides the new Ioniq 9, the plant will also make the Ioniq 5 crossover, which is already super popular.
Yeah, building core models like the Ioniq 5 and the upcoming Ioniq 9 right there in the U.S., that's a deeply strategic move for Hyundai. The source explicitly connects choosing this location to specific advantages.
And the most immediate benefit they mention is eligibility for those consumer tax credits, right?
Yes. The article points out that having final assembly in North America and using North American source batteries, which we'll definitely get to later, makes these U.S.-built EVs eligible for the $7,500 federal consumer tax credits.
And those credits can make a huge difference in the final price for people buying the car. The source does mention, pretty neutrally, that the future of those specific credit rules might be, under review.
True. Politics change.
But building the plant here definitely positions Hyundai to benefit if the credits stay, or if they're structured to favor U.S. production down the line.
Absolutely. And beyond the credits, the source highlights another strategic plus, creating a buffer against potential future tariffs.
Trade protection.
In this global trade climate, having significant manufacturing capacity inside a key market like the U.S., it insulates the company from potential import duties or trade barriers that could mess with profits or car prices.
Makes sense. It makes their U.S. operations less vulnerable to, geopolitical shifts or trade policy changes. And the source makes a kind of broader point about their positioning, too.
Yeah, by making this massive dedicated investment now, the article suggests Hyundai is putting itself ahead of many rivals.
Getting a jump start.
Kind of. While other car makers are also investing in U.S. EV production, starting a facility of this specific scale and specialization completely from scratch. It gives Hyundai a potential head start in optimizing their EV manufacturing processes right here on U.S. soil.
It's like planting a very, very large flag in the ground for their U.S. EV ambitions. Okay, now, let's shift gears to what is arguably the most fascinating part of the Metaplant described in the source. The incredible level of automation. The article flat out states this is North America's most heavily automated factory. It's meant as a showcase for integrating AI and robotic tech.
This is where the meta in Metaplant really, comes alive. It's not just about having robots scattered around. It's about a deeply integrated sort of intelligent network of automated systems all working together. The source really emphasizes that the technology isn't just there. It's fundamental to the whole operational design.
And they give a number just to give us a feel for the scale of this robot workforce.
Yes. The article mentions around 850 robots in total operating inside the plant, working alongside the human employees who Hyundai calls Metapros.
850 robots.
Yeah.
Okay. And among those, one specific type of robot gets a lot of attention. AGVs, automated guided vehicles. The source says there are about 300 of these just quietly moving around the factory floor.
And unlike older systems, that might follow fixed tracks or magnetic strips on the floor,
Yeah, the old school ones.
the source highlights that these AGVs need no tracks at all. They navigate autonomously using sensors, cameras, sophisticated mapping tech.
And critically, especially in an environment where humans and robots work together, they can intelligently sense and avoid human workers.
That's essential, yeah.
Yeah.
For safety and just efficient movement through shared spaces.
So what's the main job of these 300 AGVs? The source says it's
The
logistics.
sophisticated logistics, yeah. They are the mobile part of an AI-based procurement and logistics system.
Okay, tell us more about that system. How do the AI and the AGVs work together?
So the AI system is constantly analyzing the production flow, figuring out the material needs at every single workstation, basically in real time.
Wow, okay.
It then automatically assigns tasks to the AGVs to go ferry the required parts. So an AGV gets dispatched, picks up components from storage or wherever, and delivers them to the exact workstation exactly when they're needed for the next step in assembly.
That sounds like a super optimized, dynamic, just-in-time delivery system, almost like personalized delivery for every workstation.
That's a good way to put it.
Instead of having big piles of parts cluttering up the assembly line, the necessary bits arrive precisely when the worker or the robot needs them.
That's exactly the benefit highlighted by Jerry Roach, who's the senior manager of General Assembly, quoted in the article. He really emphasizes this shift away from human decision-making in parts delivery
Right.
towards automated intelligence. His quote is pretty direct. They're delivering the right parts to the right station at the right time, so you're no longer relying on people to make decisions about what part goes where and when.
That optimization must have real, tangible benefits, beyond just sounding cool and futuristic.
Oh, significant benefits. It dramatically cuts down the need for large, space-hogging inventories right there on the factory floor.
Free space.
Saves space, cuts down material handling time, minimizes the risk of grabbing the wrong part, and ultimately, yeah, it cuts costs. It just streamlines the whole flow of materials through this really complex system.
And the source gives this really vivid, kind of surprising example of what the AGVs can do that goes beyond just delivering parts bins. It really shows the level of task automation.
Ah, yeah, the finished car trick. It's a fantastic illustration of how versatile these AGVs are.
So what happens?
The article describes how, when a finished electric Hyundai rolls off the final assembly line, two sled-like AGVs just slide underneath it.
Okay, picturing that, sliding under a brand new car. That's pretty cool already.
All right, and then these AGVs grab and actually hoist the vehicle up by its wheels. And without any human driver getting in the car, the AGVs then autonomously ferry the entire finished vehicle away to a designated parking spot or staging area.
So a job that would normally need a human driver to move every single car off the line, it's completely automated by these intelligent vehicles. That specific example really hits home the level of advanced, almost custom automation they have there. It's a concrete demo of robots taking over what was definitely a human-driven process before.
It takes a manual, repetitive, and pretty time-consuming task for a human driver and makes it totally automated, precise, and probably faster too. It's a perfect example of using automation for a very specific, high-volume need right at the end of the line.
Okay, moving beyond logistics, robots are obviously central to the actual assembly process. The source spent some time describing the welding shop.
Yeah, the welding shop is presented as this major hub of robot activity. The article calls it an army of robots. There are 475 robots just dedicated to that area.
475 robots just welding. What's this army doing?
Their main job is cobbling together what the source calls bodies in white.
Bodies in white. Okay, explain that.
For anyone not familiar, the body in white is the stage in making a car where all the sheet metal bits, the chassis, the body panels, everything are welded together before any paint, before the engine or seats go in. It's basically the car's metal skeleton.
Got it. So these 475 robots are building the fundamental metal frame of the car, welding thousands of pieces together with incredible accuracy.
Precisely. The article highlights their speed and precision, describes them working with ruthless speed and precision.
Ruthless.
In manufacturing, getting that precision right at this early stage is absolutely critical. Any little misalignment here can cause huge problems later on down the assembly line. Robots just excel at this kind of highly repetitive precision welding.
Then there's the stamping plant, where the body panels themselves are formed. The source mentions a surprising detail here. You'd think a place where giant metal presses are shaping steel would be, well, deafening.
Right. You'd expect to need serious ear protection. Yet, the article notes that the stamping facility at the Metaplant is remarkably quiet.
Really?
Quiet enough, in fact, that ear protection isn't required.
That is genuinely unexpected for a stamping plant. What does that tell us about the automation there?
It suggests a mix of things. Probably advanced noise reduction tech in the machines themselves, plus a very high degree of automation that just minimizes how many humans need to be right near the loudest processes.
Okay.
The source describes a whirling mass of robots stamping out the roofs, fenders, hoods.
And then these freshly stamped panels, they're automatically handled too.
Yes, the article mentions they get automatically stored in these soaring racks overhead, again, minimizing human handling of big, potentially awkward metal parts. This automation in stamping and storage, it cuts down manual labor, improves efficiency, and probably contributes to that surprising quietness by keeping people away from the noise source.
This leads us nicely into another really interesting category of robots mentioned, collaborative robots, or cobots. This is where that line between human work and machine work starts to get pretty blurry in the workspace.
Yeah, cobots are designed specifically to work directly alongside human workers, without needing those traditional safety cages or barriers you usually see around industrial robots.
How do they do that safely?
They use sophisticated sensors, cameras, force feedback systems. Basically, they can detect when a human is nearby and ensure they operate safely, even in close quarters.
And the source gives a specific example of a task where a cobot is being used really effectively, something Jerry Roach calls a big technical first.
That would be installing the car doors on the assembly line. Roach explains that putting car doors on is actually notoriously tricky for humans.
Really? Why?
Well, doors are bulky, they're heavy, and you have to maneuver them into a really tight space without scratching the car's nice, fresh paint job.
Ah, right. Requires strength, coordination, and extreme care to avoid expensive damage.
Exactly. It's physically tough and really prone to errors if you don't do it perfectly every single time. And this is where Roach highlights the robot's advantage. He's quoted saying, "Guess what? Robots do that perfectly. They always put the door in the exact same place."
So the reason for using a cobot here isn't just speed, it's fundamentally about eliminating errors. In a task that's critical for quality and finish, where human inconsistency can cause defects.
It's leveraging the robot's strength, its ability to repeat a complex motion sequence identically every single time with like sub-millimeter precision. It achieves a level of consistency and quality that's just incredibly hard for a person to maintain over an entire shift.
Is the human still involved?
Likely, yeah.
Yeah.
The article implies collaboration. Maybe the human presents the door or oversees it, but the robot handles the really precise, heavy, and potentially paint-damaging part of the installation.
Okay, the article then goes into the really cutting-edge stuff, almost science fiction territory, mentioning Boston Dynamics robots being integrated into the factory, which, given Hyundai owns Boston Dynamics, kind of makes sense they'd use their own tech.
It's a perfect example of that vertical integration of advanced tech, right? They own the robotics company, so they can plug their capabilities right into their own manufacturing. The source highlights two types of Boston Dynamics robots.
First up, Spot, the robotic quadruped, the four-legged, dog-like robot that's all over the internet doing amazing things.
Yeah, Spot. And the source describes a very specific, very interesting job for Spot at the Metaplant. They use its 360-degree vision and what the article calls its athletic intelligence.
That's athletic intelligence.
Basically, it's advanced mobility and spatial awareness. They use that to perform quality control checks, specifically sniffing out potential defects on car welds.
That's a fascinating use case. Checking welds is vital, but must be tedious and hard for a human eye to do consistently over a whole car frame.
Right. Spot's ability to navigate tricky, confined spaces and use its vision systems from all sorts of angles makes it potentially really good for this detailed inspection work. It could spot subtle flaws a human might miss, or ones in really hard-to-reach spots. It's a super high-tech quality assurance role using mobility and advanced sensors.
And then there's the mention of Atlas, the humanoid robot. This is the Boston Dynamics robot that's maybe the most famous one, often seen doing incredible acrobatics in those viral videos, which, as the source notes, has definitely led to some public speculation.
Yeah, Atlas's public demos of breathtaking physical skills, including crawling, cartwheeling, and even breakdance moves, have observers wondering if auto workers are next in line to be replaced by AI. That's according to the article.
It taps right into that big societal conversation, that concern about automation taking jobs.
It's the most visible symbol, maybe, of the fear that robots are coming for human jobs, especially in manufacturing.
But the source addresses this directly. based on what Hyundai executives are saying.
And it directly addresses that perception, yeah, by quoting or paraphrasing Hyundai execs. Their position, as presented in the article, is that Atlas is explicitly not meant to replace human auto workers.
Okay, so if not replacement, what is Atlas's planned role in the factory?
The source explains that Atlas models are currently being trained for factory tasks. They use sophisticated RGB cameras in their swiveling heads, which the article actually describes as charming,
Charming. Okay.
to sense their environment, navigate complex areas, avoid bumping into things or people, and importantly, manipulate and move parts around.
And the description mentions they do these manipulations in impressively complex sequences.
That suggests Atlas is being geared up for tasks that need more dexterity, more manipulation skill, and more environmental adaptation than, say, simpler robots can manage.
Like what kinds of tasks?
Imagine tasks like picking up awkwardly shaped objects, maybe navigating around unexpected obstacles on the floor, or performing sequences of movements that aren't as rigidly programmed as a typical assembly line robot's path. More flexible work.
And the plan is to deploy these Atlas robots not just at the Metaplant, but across Hyundai's global factories.
That's the plan mentioned, yeah, throughout their global manufacturing network. The source also includes the detail, just noting it neutrally, that the Boston Dynamics robots, including Atlas, are non-union.
Interesting context. Okay, bringing it back to the human workers, the Metapros. How do Hyundai execs square this massive investment in advanced robotics, including potentially deploying humanoids with the human workforce?
The source circles back to Jerry Roach's perspective again, which is framed as being focused on improving the quality of human work. He argues that robots, including these advanced ones, are there to free people from the jobs nobody really wants.
The dull, dirty, and dangerous stuff.
Exactly. The heavy lifting, the super repetitive motions, the mundane and physically demanding tasks that aren't just unfulfilling, but can be hazardous or lead to injuries over time.
So the robots take the worst jobs, basically.
That's the argument presented in the source, yeah. And it allows the human workers to shift their focus. Roach is quoted emphasizing this shift very clearly, saying, "I want my people doing craftsmanship."
Craftsmanship. That single word implies a really different role for the human worker in this super automated place.
It really does. Instead of just being, cogs in a repetitive machine, the humans are envisioned as focusing on tasks that need unique human skills.
Like what?
Like precision tasks needing dexterous fingers for fine manipulation, visual inspection that goes beyond what a sensor can see, intelligence for problem solving and adapting on the fly, and the kind of skill that comes from human training and experience. It paints this picture of human-robot collaboration, where each side does what it does best.
Now, the Metaplant isn't just about pushing automation. The source also highlights significant efforts towards sustainability and green logistics. These seem built into the design from the start.
Yeah, this is presented as a core principle of the place, not just some greenwashing add-on. I mean, building EVs is obviously about cutting transport emissions, but the plan itself aims to minimize the environmental hit of the manufacturing process, too.
And Hyundai has set a really ambitious target for the plant's energy use.
Very ambitious. They're targeting getting 100% of the plant's energy from renewable sources. That's a huge undertaking for a facility that must use a massive amount of power.
The source gives one visible example of how they're working towards that right on site.
The parking lots, yeah. Nearly 1,900 parking spaces are covered by solar roofs.
Not just for shade, then.
Nope, they actually contribute to the plant's power needs, providing up to 5% of the plant's total electricity right now. It's a visible, everyday reminder of that commitment. And the article notes the Metapros get to park there, shielded from the hot Georgia sun, which is, a small but nice perk.
Beyond the solar on-site, they're also integrating hydrogen power into their logistics chain.
This is another forward-thinking approach mentioned in the source. They have a fleet of 21 hydrogen trucks. Specifically, Hyundai's own Xcient fuel cell trucks.
And these are special.
The company describes them as the world's first commercialized hydrogen fuel cell semis.
Wow. Okay, what job do these hydrogen trucks do?
They're used for hauling parts from suppliers in the area to the Metaplant. The source points out the key benefits. A decent 400-kilometer driving range, good for regional runs.
And the emissions.
Critically, zero tailpipe emissions, just water vapor.
So they're trying to green the supply chain bringing stuff in, not just the vehicles going out.
Exactly. It's a more holistic view of cutting their carbon footprint. And they carry that green logistics thinking through how they ship the finished cars out too.
The source mentions a strong preference for using trains.
Yes, the bulk of the finished cars made at the Metaplant will be shipped out by rail rather than just trucks.
Yeah.
Shipping by rail is generally much more energy efficient per vehicle than trucking is, especially over long distances. So that strategy helps trim fossil fuel emissions further and reduces the automaker's overall carbon footprint linked to distributing their cars.
We've talked about the Metapros and their changing roles alongside robots, but let's look at the actual numbers involved in the human workforce as the source details them.
Yeah, it's really important to remember that even with all this automation, it's still a massive human operation. The plant currently employs 10,340 Metapros.
And that number is set to grow significantly, right?
Oh, yeah. The company forecasts an eventual workforce of 8,500 people working directly on site at the Metaplant.
8,500 direct manufacturing jobs. That's huge.
It really is. And the economic ripple effect doesn't stop there. The source estimates another 7,000 indirect jobs will be created for local suppliers and supporting businesses in the area.
Wow, so combined, that's potentially 15,500 jobs tied directly or indirectly to this one facility. That's got to be transformative for the local economy, for Bryan County and coastal Georgia. The article gives details on pay, too.
The average annual pay for a Metapro is reported as $58,100.
And putting that in local context, how does that compare?
That's key, yeah. The source notes this average pay is 25% higher than the average wage in Bryan County itself. So these aren't just lots of jobs. They're relatively well-paying jobs compared to the local standard.
That's significant.
And even with the current workforce, the annual local payroll coming out of the Metaplant is already around $497 million, nearly $500 million. As the workforce ramps up towards that 8,500 goal, the economic boost for the community will be even bigger. It really shows that large-scale manufacturing, even highly automated, still brings major economic benefits through jobs and wages.
Now, a absolutely critical piece for any big EV plant is getting a reliable, high-volume supply of batteries.
Yeah.
The source details Hyundai's huge investments in local battery production, specifically to support the Metaplant.
Yeah, localizing that battery supply chain is totally essential, not just for smooth logistics, but like we mentioned, for meeting requirements for things like those U.S. consumer tax credits.
So where are they getting batteries for the Ioniq 5s being built there right now, since the big battery plants aren't fully running yet?
Good question. The source mentions that batteries for models like the Ioniq 5 are currently sourced from existing operations in Georgia, probably linked to partners like SK On, but also some batteries are still being imported from Hungary.
Ah, okay. So that really highlights why they need this new local capacity online soon.
Exactly. And the plan is for major battery production right there on the Metaplant campus.
On campus.
Yeah. One key facility is the HLGA battery plant, located directly on the Metaplant site.
That must be a huge facility itself.
Oh, yeah. It's described as a $4 billion plant. And it's a joint operation between Hyundai Motor Group and LG Energy Solutions.
$4 billion just for the on-site battery plant. What kind of batteries will they make there?
According to the article, the plan is to start producing nickel cobalt magnesium cells, or NCM cells, starting next year, 2026.
NCM, that's a pretty common advanced lithium-ion chemistry for EVs, right?
It is, yeah. Widely used.
And will those cells then be assembled into the full battery packs right there as well?
Yes, the source notes the cells made there will be assembled into battery packs by Hyundai's own Mobi subsidiary right there on campus.
So that's a highly integrated process.
Super integrated. Raw materials come in one end, cells get made, assembled into packs, and then delivered straight to the vehicle assembly line, all within the same giant complex. Very efficient.
And this on-campus plant, it isn't even the only big local battery investment Hyundai is making in Georgia?
No. They're also building a second, equally massive battery facility somewhere else in the state.
This second plant is even bigger, investment-wise.
It's a $5 billion plant, so another huge project on its own. The second one is a joint operation with a different partner, SK On.
Okay, let me get this straight. 2 enormous battery plants in Georgia, totaling $9 billion in investment just in local battery-making capacity. One feeding the Metaplant directly, the other providing more supply and maybe some backup.
That's right. And putting these battery investments into the wider context of Hyundai's overall U.S. investment plan is really eye-opening. The source states Hyundai plans to invest a total of $21 billion in the U.S. between now and 2028.
$21 billion by 2028. And the article gives some history for that number, which makes it really stand out, doesn't it?
It really does. It notes that Hyundai has invested a total of $20 billion in the U.S. market since they first entered way back in 1986.
Wait, Hang on, so they plan to invest more in the next, what, 4 years than they have in the previous nearly 40 years combined?
That is precisely the implication. $21 billion in roughly 4 years versus $20 billion over 37 years. That staggering acceleration in investment just hammers home how critical the U.S. market is for Hyundai's future plans and how intensely focused they are on localizing their EV production and supply chain right here.
That's incredible.
The source even has a nice line about it, suggesting that even a robot could crunch those numbers and come away impressed. It's just a massive, accelerated, long-term bet on manufacturing in America.
Okay, bringing all these threads together, the huge scale, the crazy automation, the human workforce, the green efforts, the local battery production, the source makes a final point about the Metaplant's strategic advantage, tying back to its original design.
Yes, the article comes back to that core idea. This facility was designed from the ground up, specifically as an electrified car plant. This is presented as its fundamental strength.
And why is that ground-up design such a critical advantage compared to maybe other manufacturers?
The source contrasts it directly with automakers, and it names specific examples, like Tesla's operations in California and Rivian's plant in Illinois, who are using or had to adapt existing factories. Factories originally built to make internal combustion engine cars.
So instead of trying to shoehorn EV production into old layouts, old infrastructure, old processes designed for gas engines, Hyundai started with a completely clean slate.
Exactly. That let them optimize the entire layout and every process specifically for the unique needs of EV production. Things like handling those huge battery packs, integrating complex electrical systems, leveraging robotics and logistics from day one in the most efficient way possible.
It means the whole factory is built for the product it's making.
Right, rather than having to make compromises based on legacy constraints from a previous era of car building.
It really positions the Metaplant not just as another new factory, but as a potential model for what future manufacturing might look like. This highly integrated system where advanced robots, human skill, sustainability, and a local supply chain are all purpose-built to work together efficiently.
It represents a really holistic view of modern manufacturing, recognizing that building the next generation of vehicles means optimizing the whole ecosystem of creation, from the energy powering the plant to how parts move around the floor to the specific jobs given to people versus machines.
So just to quickly recap our deep dive into this really fascinating IE Spectrum article on the Hyundai Metaplant down in Georgia. We've journeyed through the sheer scale and ambition of this place, set to be North America's largest dedicated EV plant.
We've explored that sophisticated blend of robots and AI, from the hundreds of AGVs doing complex logistics, even moving finished cars, to the army of welding robots, and the really intriguing potential roles for those Boston Dynamics bots and Atlas humanoids working alongside people.
We've seen the major commitment to sustainability, aiming for 100% renewable energy with things like solar roofs and pioneering hydrogen trucks, plus the strategy to cut emissions using rail transport.
We've highlighted that crucial human element, the thousands of Metapros whose jobs are evolving towards craftsmanship and skill alongside the robots, and the huge economic impact their jobs and wages bring to the local area.
And we've unpacked that massive accelerated investment in local battery manufacturing, which is key for supply chain security and strategic market positioning, including getting those consumer incentives.
So why does taking this kind of deep dive into one specific factory matter to you listening? Because it's not just about cars, right? It's a real, tangible example happening right now of the future of manufacturing in action.
Yeah.
It shows a concrete case study of how high-tech automation is mixing with human expertise and environmental goals on a scale we haven't really seen before.
It gives you a clear window into the technological, the economic, and even the societal forces that are shaping not just the cars you might drive soon, but also the very nature of work and industrial production itself.
And it leaves us with some genuinely thought-provoking questions to chew on as this place ramps up and the tech keeps evolving.
Absolutely. For instance, considering the level of automation we've talked about, especially the plans for integrating sophisticated robots like Atlas for potentially more complex tasks, how might the roles of those human workers, the Metapros, focusing on craftsmanship, how might their roles continue to change and evolve over the next 5, 10, maybe 20 years?
Yeah, what new skills become most valuable? How will that human-robot partnership really play out in the long run?
It's a big question.
And think about that goal of 100% renewable energy. For a facility this enormous, What are the real-world infrastructure challenges and innovations needed to reliably power such a massive operation entirely with clean energy, ensuring constant power for thousands of robots and people?
It highlights the broader energy transition hurdles facing all heavy industry, doesn't it?
Definitely. Both are huge questions with implications way beyond just the walls of the Metaplant.
Something for you to keep mulling over.